thank you everyone for coming to our talk. And today we're going to tell you about how you can make your services more reliable using Stackdriver. So today we have essentially 4 things that we want to tell you about. First of all, we're going to tell you about why DevOps, why SRE, kind of how do these things help you solve reliability problems. Then we'll tell you about 3 specific things that GCP and Stackdriver do in order to make it possible for you to achieve SRE principles on Stackdriver and on GCP. So we're going to tell you about how to measure success with service level objectives. We're going to tell you about how to improve your service level resiliency by having better alerting and better debugging. And then we'll tell you about how transparent SLIs help you get shared visibility into Google Cloud Platform. So I'm Fong-Jones. I'm a staff site reliability engineer, and I've been working at Google as a SRE for about 10.5 years. And it's been across 8 different teams, so I've kind of spanned everywhere from consumer-facing products like Google Flight Search to all the way down to low-level storage like Google Cloud Bigtable. And now I work on the customer reliability engineering team, which I'll tell you about later. But the key mission that we have is we help GCP customers build and operate reliable systems.
And I'm Marie Cosgrove Davies. I'm a product manager on Stackdriver, focusing on logging. I'm new to Google, but I've been in ops for a long time, and I've had a number of job titles, including SRE, product manager now, and support and engineering.
So first of all, I wanted to lead off by telling you about how does SRE help you improve reliability. But before I even do that, I kind of want to lead off by talking about why should you care about reliability? Why should you care about operations? And this may seem obvious to some of you, but who have done operations before. To others of you, it may be a new concept, right? That as people who develop software, we tend to spend a lot of time thinking about, when does my feature ship? OK, I spent a month shipping my feature. I spent, 6 months shipping my feature. What happens afterwards? And it turns out that if you spend a month developing your feature, it might take a month worth of support work later, or it might even take 10 times as much. You might wind up spending for every month that you spend developing a feature, it may end up having someone spend a year supporting it. So it's really, really critical that we think about how do we improve the operability of our services to lower the cost of ownership of our services. So SRE and DevOps try to solve this problem. So why is this problem so bad? If you think about the way that we used to operate services, I was a sysadmin way back in the day, right? We used to have a world in which people who were product developers wanted to ship features as quickly as possible. And then you had operators who were told, keep the system as stable as possible. We want 100%. And these 2 interests are in diametric opposition to each other, right? You have product developers who are speaking the software engineering language who are saying, why is my feature not out yet? And you have operators that are saying, my boss will punish me if I don't get 100% uptime. You can't ship that feature, right? So that's not a very healthy state. So how do we get out of this state? The good news is we have some lessons that we've learned from the practice of Agile, from the practice of making sure that your product management and your software engineering teams are on the same page as each other, right? That's what Agile is about. Agile is about kind of reducing that barrier, reducing friction, shipping smaller increments faster. And the good news is that DevOps is a way of solving this problem and solving this wall between development and your software operations team, right? And says that you need to break down that wall. So DevOps is kind of an abstract interface. It says that it's a set of practices and guidelines that say you should make sure that you dismantle these walls between IT, operations, software development, and so forth. But it doesn't say exactly how do you go about doing that. Right? It leaves a lot of it up to you as a person implementing it to figure out what you want to do. In comparison, SRE, or Site Reliability Engineering, is a set of practices that were originally developed at Google and have spread across the industry, and it's much more prescriptive. It says, here are some practices, here are some concrete beliefs and philosophies, and here is a job role. You'll notice that as much as people like to hire for DevOps engineers, there is no such thing as a DevOps engineer. Whereas you can hire a site reliability engineer and have a relatively clear idea of what does that job description mean. So what is in that job description, right? The core idea behind SRE's solution to this problem of the wall between development and operations is that we have to use data to guide our decision making. SRE says that we need to treat operations just like any other part of software engineering. That we need to really engineer things, right? That we need to write automation to deal with our problems. That we need to not be doing things by hand all the time. And that, furthermore, we can't bolt reliability on after the fact, that we have to make sure that our systems are engineered to be reliable right from the start. In terms of what SRE teams actually do, right, like, we are a solution for having your systems run at large scale, scalably, reliably, and efficiently. So I don't have time to go into kind of all of these detailed practices, kind of core competencies that SREs are expected to have. For more information on that, you can go to a talk tomorrow afternoon. But I did want to quickly summarize kind of what are the areas, right? SREs think about metrics and monitoring. How do we know whether our systems are working? How do we debug them? How do we make sure that our systems can scale up appropriately? How do we make sure that we can push software to production in a safe manner? And when things do break, how do we make sure that we get the system back within parameters in a reasonable amount of time? And overarching all that, we like to think about the culture. How do I keep operating this software at scale without causing myself to burn out? Not today, not tomorrow, but a year from now, 2 years from now, 3 years from now. So that's kind of in general what we think about as SREs. And you may be asking, OK, so you've said a bunch of stuff, but how does this relate to DevOps? So I said earlier that DevOps was an interface, right? That it was an abstract interface that said, here are some general ideas. It's up to you to figure out how to do them. So these are the 5 areas of DevOps. DevOps says that you need to reduce your organizational silos. It says that we need to have an idea of failure as normal rather than expecting 100%. It says that we need to gradually roll things out, that we need to gradually change our processes, and that we need to use tooling and automation, and that we need to use measurement as the centerpiece of everything. So it turns out that SRE and DevOps are not that far apart from each other, and that every single practice that DevOps says you should have an implementation for, SRE does this. So today we're going to tell you about 2 specific ways that SRE implements DevOps. Specifically, we're going to be telling you about error budgets, and we're going to tell you about how to reduce the cost of failure. So hopefully we can go into a fair bit of depth here so that you have an idea of concretely how can Stackdriver, how can GCP help you in each of these 2 areas. So Marie, why don't you tell us about error budgets?
All right. So I'm going to talk a little bit about error budgets and SLOs. Now, one of the core observations of site reliability engineering came from Ben Trainor-Sloss, who's the head of all SREs at Google. And he noticed that 100% is the wrong target for everything. Like pacemakers, maybe. Nuclear missiles, maybe. But pretty much everything else, you don't need 100% reliability. And why is this? If you're running an app, the network is not 100% reliable. Your users' phones are not 100% reliable. They can't tell if it's your app or the network or your phones. Also, additional levels of reliability require additional expense. Google has observed that for every 9 you add of reliability, and we'll talk about what that means in a minute, you're adding 10x the expense. So it gets much, much more expensive. You hire ops people. You have to have additional fallbacks and fail-safes, and you have to build for it. Since we're not the airline industry, mostly, we don't need to. So how do we figure this out? We use a concept called error budgets. And in order to define an error budget, product management and SREs will talk, and we'll figure out what we think the users are going to be happy with. And from that, we subtract whatever level of availability we think the users need from 100%. And the amount that's left is the amount we're allowed to be down in a given window. So that's our error budget. Once we have an error budget, we need to track it. It's really important that we monitor the actual availability, because otherwise we don't know how much of our budget we've gone through. It's like if you have a budget for spending and you don't track how much you spend, then it's not all that useful. And when you're monitoring that, it gives you a control loop for your error budget. If you have a ton to spend, then you can do more releases. You can have more features. If you run out or you're running low, you need to be more conservative, because you know that your users are going to be unhappy. So how do we measure reliability? What is this metric? There's a naive approach, which is to say, OK, well, we can figure out availability. That's the number of good minutes over the number of total minutes. And that's the amount of time a service is working. There are some advantages to this approach. It's super intuitive. And it's pretty easy to measure for a continuous binary metric like uptime. There is one major disadvantage, which is how many of us are running services that are actually up or down. It's really hard for distributed systems to make sense of this. So there's a more sophisticated approach that you may want to use as well, which looks at interactions. You take the good interactions over the total interactions, and that's the fraction of real users for whom the system is working. Another advantage of this is it brings the focus back to the user, who's really the person we're concerned about in the first place. So this handles our distributed request response service as well, and it enables cases like, is something that's down and not getting requests, do we care? No, because we're not getting any interactions. If a few of our services are down and they are getting requests, what's our availability? We look at the interactions, there we go. This is a hard-to-read chart. For me, at least, when I think about 99% or 99.9% or 99.99%, it's a little difficult to keep those straight because they're all really similar. They're all really high numbers. It's more useful for me to think about the error budget that I'm allowed. Per 30 days, for instance, if I have 3 nines of availability, that's 43 minutes of downtime. If I have 4 nines, that's 4.32 minutes. So there's a dramatic difference if I'm operating a system in how I need to react to an outage if I'm expected to have 4 nines of availability.
The other really interesting thing about this, of course, is that we're assuming 100% down here. But earlier, Marie, you were talking about bad interactions and good interactions. So if I were serving 10% errors, I might still be able to have 99.99% of my requests complete successfully over 30 days for up to 40 minutes if I were only 10% down rather than 100% down. So it lets us be a lot more nuanced about approaching this.
Yep, but that's real hard to represent in a table, so this is what you get. A glossary of terms before we go into more of this. I'm going to be talking about several of these. A service level indicator, or SLI, is a well-defined metric of good enough. And that's what we were talking about before, your metric that helps you figure out your error budget. A service level objective is a top-line target. So you combine this with an SLI, and that tells you what your goal is. And a service level agreement is a legal agreement between you and a user. If you fall below your SLA, then there's some sort of penalty. Usually you will pay the user. We won't really be talking about SLAs in this talk because neither of us is a lawyer, and we think the operations side is more interesting.
So to talk concretely, briefly about what an SLI is and what an SLO is, you can think about an SLO as being like, I want this request to the home page to complete in 300 milliseconds. If it completes in 300 milliseconds, the SLI is good. And if it completes in more than 300 milliseconds, then the SLI has gone sour. The users are not quite happy. And the SLO is the top-line target that says that we expect 99.99, for instance, % of those requests to complete successfully over a window, to make it a little bit more concrete.
That's exactly right. So how does Stackdriver help you with SLO monitoring? We have an EAP product that allows you to define, track, and alert on SLOs directly within Stackdriver monitoring. I'm just going to walk you through the UI. It's very intuitive. The first step is to figure out if you're going to have a latency or availability SLI. If it's latency, you'll define a number of milliseconds. The second is to look at the period. In this case, we're looking at a week or a month. And the third is to look at your goal, or your SLO. Now, based again on our research, 3 nines you can get from well-engineered software. 4 nines you can get from well-engineered operations. And 5 nines, you need a well-engineered business that's really focused on availability. And as you'll see from these very cunning dollar signs that we've put on here, it gets incrementally more expensive for every 9 you add.
So you may want to think about, does it really matter if your users see downtime for 4 seconds per month? Maybe, maybe not. It's an important thing to think about. What is your specific use case?
And then we have a review where we confirm that it looks right. We submit, and we start tracking. So once we're tracking our SLO within Stackdriver monitoring, this is what it looks like. We get 3 graphs, availability, in this case, in the calendar week, and it shows us what our SLO target is. We have our error budget and how we're doing. And we have our SLO compliance. So in this case, we're not doing so great.
Nope, not doing well at all. So now that we've defined our service level objectives, you may ask, that's great, but how do you actually defend them? How do you actually make sure that you meet your service level objectives? So let's talk about the life cycle. Let's talk about how do we manage to run a control loop? How do we manage to keep our services running according to the service level indicators and the expectations? So typically, your service level objectives are met. Like maybe you have 0.5% errors or 0.001% errors, but in general, your users are happy, everything is fine. But inevitably, faults do happen in our systems. Whether it's a code push, whether it's a config push, or a surge of user traffic, something will happen inside of your system that is a fault. And at that point, what happens is your service level indicators start going sour because users are having a bad experience, and Stackdriver SLO might eventually let you know that your error budget is in danger. So your alerting might fire, and then we have to do things as the people who are responding, right? We have to see, is everything 100% down globally? If so, I might want to involve more people. Can I do something quickly like draining a zone? If so, maybe I'll do that. But then after that, we wind up spending a lot of time in the course of figuring out what happened in this loop. We wind up having to formulate a hypothesis of what we think broke in our system, and then we wind up having to test the hypothesis and actually verify, is this actually what is going on in my system, or did I come to the wrong conclusion about what is actually broken? And assuming that you've identified the right thing, then you go and develop a fix. Maybe it's provisioning more capacity. Maybe it is reverting the bad rollout. But you have to develop a fix, and you have to test the fix. And ideally, everything goes back to normal, right? Everything goes back to nominal conditions, and your SLO is met again. And fortunately, how many of you have ever had a situation where your first guess was right about what broke in the system, right? How many of you, it happens every single time? No one's raising their hands. Good, none of you are overconfident, right? Like, we spend a lot of time because our hypotheses are not always correct, or our solutions are not always correct, right? So we wind up going back to square one over and over and over again. So it's really, really important for us to both have high quality alerting to make sure that we find out quickly, but without waking us up too much. And then we need to make sure that we're actually getting to testing and formulating hypotheses relatively quickly. So let's start with the high accuracy alerting bit, right? We want to make sure that we don't burn out, that we're not getting paged 30 times in the middle of the night at 2 a.m. every single day. At the end of the day, what matters is that we have to monitor the symptoms of what are our users actually seeing, and not every potential root cause. What do I mean by this? Well, so users care if they can use their service, and getting alerted about things that don't actually impact your users doesn't really matter, right? Does it really impact your users if one of your VMs has its hard disk fill up? Does it really matter? Probably not, but it kind of depends on what your users are experiencing. So what about if your Paxos quorum changes? Or what about if the CPU load on one machine is too high? Or what if the queue length on your Kafka queue is too long? Or what if your task restarts? Or what if the kernel panics, right? Like, all of these possible things that could possibly go wrong. Not every single one of them is worth waking up for. So it turns out that there's a better way of thinking about this, right? Because if we're already measuring your service level objectives are measuring user happiness. So what you care about is figuring out, is your user happiness impacted? For instance, if I had an availability SLI that said, this is the fraction of HTTP 500s that I'm willing to serve, and any more than that is not acceptable, that is an end user symptom. How many 500s am I serving? And I can use that to my advantage to replace all of those other alerts that I showed you, right? And get rid of them. Because all I care about is, are my users seeing errors or not? But there also needs to be another strategy to this, because we need to make sure that we don't have too many false alarms, right? But that we also detect low-level degradations in our systems. So we have to go back to our service level objective and say, what's an acceptable burn rate? And how will I know quickly enough to react in the event that I'm going to consume weeks of my error budget in a matter of hours or minutes, right? As well as being able to keep track of, am I having 10% more errors than I'm allowed, right? Am I getting, instead of 0.1% errors, 0.11% errors over a longer window? So this means that I need to think about, what are my thresholds, right? I need to think about the math. I need to say, if I'm overspending and I'm spending 5 hours of error budget in a single hour, I should probably fire off a page, right? I should probably wake someone up and have them immediately deal with it. Or if I've overspent by 5% or 10% over a few days, it's been going on for a few days. It will probably take multiple weeks to burn through my error budget. It can wait to the next business day. It can wait for someone to look at it. It's still urgent, but not waking someone up urgent. And that way you get enough time to get that statistical signal of, is something actually broken? Right, so essentially what we've done is we've said, if we overspend by too much within a given window, for instance 1 hour, that we need to fire that page. But also, if we burn faster than 5 or 10 times the rate that I'm allowed in my budget, for instance, if I wind up burning through 7 hours of error budget in 5 minutes, I'll get notified right away. There's no need to wait the full hour. Similarly, we can talk about the slow burn case, right? We can say, OK, I'm going to measure over 3 days, And if I see 5% more errors than I expect, then I'm going to file a ticket. I'm going to get a JIRA ticket or whatever, right? Or if I even cross that threshold within 1 day, I can still get a ticket and deal with it, and it'll be fine. So the good news is you don't have to implement all of that math yourself, because Stackdriver SLO will deal with that problem for you. Stackdriver SLO will let you send alerts when your error budget starts being exhausted. It will project out into the future, and it will say, if I'm going to exhaust my error budget within a certain window of time, then I need to be alerted. Or if I have less than 10% of my error budget for the month remaining or for the week remaining, to alert me. And that is how you get rid of all of those potential cause-based alerts and instead replace them with service-level objective-based monitoring. So that's great, right? Like, we've now addressed the time to detect problem. But let's talk also about the time to resolve problem, because that's also an equally important part of having a resilient service. So when users see errors, right, now we have our service level indicators going sour. Stackdriver SLO alerts us because we're burning through our error budget too fast. What do we need to do? As I said earlier in the debugging cycle, we need to prioritize the speed of our mitigation and recovery. So this is where a technique called layer peeling comes into good effect. And it helps us localize problems within our stack. What zone is it coming from? Which Kubernetes pod is it coming from, right? These are useful questions that we need to be able to answer. So I'm showing you how Google SREs debug tooling using our internal infrastructure, which has then influenced Stackdriver to develop features that help everyone do it rather than requiring you to be a Google SRE. So in this example, for instance, let's say that I've been paged for a latency service level indicator, right? That I've started seeing that my 95th percentile latency has gone over 100 milliseconds. So I might need to do something like ask a question like, hey, can you break this down for me by zone within the region? So if I do that, then I might get useful data that says, hey, US West 1B has been slow for a while, but that's not where the excursion came from. The excursion came from US West 1A. And then I can drill down into US West 1A, and I can see that it's 2 specific replicas that are slow. And then I can even do something more sophisticated and say, you know what? Show me a heat map, right? To show me the details of what's the distribution of requests that are slow. And then that'll give me a signal of, for instance, all of the queries on this task are slow because of the fact that there is a noisy neighbor. And then I might drain it away from that machine, right? So it provides you with an actionable way of drilling down into your data. And the good news is that this is fully implemented inside of Stackdriver, inside of the Metrics Explorer. So you can go into the Metrics Explorer, and you can ask questions, and you can tell it to filter, and then you can tell it to group by a specific thing. So in the earlier example, I said I wanted to filter by region and group by zone. And then I wanted to filter by zone and group by pod, for instance, and then filter by pod and then group by individual task number. So that's how we think about being able to apply this SRE technique from Google inside of Stackdriver. So Stackdriver Metrics Explorer is really handy for doing these drill downs, because if you can't localize problems within your stack, you're taking random guesses, right? You're kind of playing whack-a-mole, seeing whether your latest hypothesis actually is where the problem is. It's better to not guess. It's better to know by exploring your data by the tags of where it came from. The second technique that I'm going to tell you about with regard to helping you with debugging problems faster and reducing your time to recover is joining, to be able to cross-correlate problems inside of your stack. What do I mean by cross-correlating problems in your stack? Well, often it turns out to be the case that we have pushed something not to any one individual Kubernetes pod or any individual zone or region, but instead that something has happened under the hood. For instance, maybe someone went and silently updated the Java virtual machine across our entire fleet, right? So if you look at all of the data, you might just see noise. Because of the fact that there's no one particular place it's coming from, some tasks are slower than others. So how do we get useful signal out of this? What we have to be able to do is we have to be able to combine latency data with other data, such as what version of the kernel we're running, for instance. So we do this all the time at Google, where we add additional information that is collected elsewhere in the system and combine it with existing data. And once we have that additional data, we can go ahead and say, hey, I want the average latency by kernel version. And if I do that, I get signal out of my noise. And that signal tells me, hey, that kernel version suddenly started having a regression, where previously all I saw was noise. So how can you do this inside of Stackdriver, you may ask? The answer is that inside of the Metrics Explorer, any other view within Stackdriver, you can select not only location-based information, but you can also select for system properties that are embedded inside of the data that you're exporting. For instance, you can export the container image ID out of your Kubernetes cluster in order to get a delta between two different values. For instance, in this example, we have set up a Kubernetes pod to serve 500s at a very fast rate, to serve 500s very quickly, because it's not taking any time to do any real work. And then meanwhile, the control group is serving a regular workload and taking a normal amount of time to do it. So being able to do this breakdown by version, not necessarily localized to any one particular location, is really, really helpful. The other thing that's really cool is that we have upcoming a feature that will allow you to issue custom queries that are not done through the UI and are instead done by typing in expressions. So this lets you combine data that you wouldn't ordinarily be able to combine. For instance, being able to calculate how many CPU seconds does each query take that my system is receiving, right? Where you have to take the total number of CPU seconds on each task and divide it by the total number of queries on each task, which are metrics that you wouldn't ordinarily be able to combine. So this core idea that I'm trying to get across to you is that having your metadata available to you inside of Stackdriver monitoring and having the query notation language available to you is a critical tool for being able to formulate and test your hypotheses. And it lets you find problems that are not necessarily tied to a specific location. So you can today do resource metadata-based queries easily within the generally available product. And we have Stackdriver query notation that's in preview that will allow you to arbitrarily join these metrics together. And if you're interested in learning more putting this to work, feel free to talk to me afterwards or come to the 5th 9 Lounge on the 2nd floor of Moscone West. The final technique that I wanted to show you for reducing your time to resolve is really, really powerful. It has seriously changed my life as an SRE. And the technique is called Exemplars. It lets you pinpoint problems within your stack by letting you reason starting from specific examples. What do I mean by this? An exemplar is essentially an association of something high cardinality with your existing distribution-based data. So it makes your distributed traces really, really useful and actionable for you. It makes your high cardinality data tags really, really useful and actionable to you. The way that it works is that we keep inside of distributions the notion of a time slice in our bucket, for instance, the window between 2:50 p.m. and 2:55 p.m., and a value slice, which is, for instance, the values between 50 and 60 milliseconds. So for each of those buckets, we record up to one example of a query exhibiting those behaviors. For instance, a Stackdriver trace that exhibits that latency during that time window. And then we can show you in Stackdriver monitoring which buckets have samples and let you go look at the samples in detail. So as I said, this is a technique inspired by Google SREs. We've been using this for several years now. And what do we actually use it for at Google? The answer is that we use it for looking at long-tail problems. For instance, it would be prohibitively expensive for us to record the amount of time that every single physical machine in Google's fleet took to boot. However, what I can do is I can record only one example for each of these common case time values, but I can also record one example for each of these outlying values, and I can find out, as a person who maintains the fleet of machines, which specific machine should I be looking for that had a slow reboot time. Or for instance, another thing that I can look at is if I have a service level indicator that is based off of a Blackbox prober. For instance, if I had a storage system where I was measuring how quickly does it take to write a query into this system. What I might observe is if I had a less sophisticated monitoring system, all I would see is that the 99th percentile is slowly creeping up over time. However, the cool thing is that this heat map gives me a visual representation of the fact that more and more of these queries are taking close to n100 milliseconds. but that there's not really that many queries over that value. So I might ask questions like, show me an example of a query that takes n hundred milliseconds, right? Show me an example of a query somewhere in here that is starting to become very slow. And I can then click on it and find a Stackdriver trace corresponding to that slow event so that I can start looking at this long tail problem rather than having to look through 20 or 30 different dashboards and guess what I think is happening. So this feature is going to be available soon in Stackdriver that lets you overlay individual Stackdriver traces onto a heat map of your latencies and display it alongside your service level objectives. So you can go directly from having a service level objective threatened to seeing concrete examples of queries that caused your service level indicators to become unhappy so that you can start debugging and formulating hypotheses faster. With these culprit traces in hand, it helps you formulate a hypothesis. It helps you figure out which task do I need to go to, which Kubernetes pod do I need to look at, right? In order to figure out which logs do I need to look at, right? Because it has a concrete timestamp and machine name to go look at. You still need to be able to dynamically evaluate queries, which is where the earlier section on joining data comes from. But even formulating the hypothesis is the thing that we find we need to optimize for. So exemplars in Stackdriver are a way of combining Stackdriver trace and Stackdriver monitoring all in one view and getting you the insights that you need faster. So now you've identified a problem, and you think it might be Google. What should I do, Marie?
So Liz talked you through some techniques that Google SREs use in order to debug more effectively. And I'm going to show you something that Google is providing to you right now, today, that will help you easily identify whether a problem that you've seen is because of Google. Now, often the first thing that we'll do when we're debugging is to try to figure out roughly where the problem's coming from. Is it my code? Is it the network? Is it the infrastructure? That can be a really tricky thing to figure out. So Google's transparent SLIs help you answer the question of, is this problem coming from the infrastructure? They give you the ability to quickly understand if an issue you're seeing is correlated with an issue in GCP. And they give you per project metrics about your requests to help you answer this question. How might you use them? For triage, if you've gotten alerted by one of your SLIs, it's trending towards violating your error budget, this gives you a single place to go to look at the GCP services that your product depends on, so you can tell. And then for support, if you do identify an issue, when you call Google support, you'll be looking at the same graph. And that helps make sure that you start the conversation on the right foot, that you start the conversation with a mutual understanding of the problem so you can move quickly towards resolution. So to view these, again, these are your requests, so they're per project, and they're broken out by a number of fields. In the Metrics Explorer today, you could go look at this right now, but please keep paying attention to our talk. Wait until after. You'll search for consumed API. And when you do this, you'll see there are 4 options: request count, request latency, request size, and response size. There are a number of different labels supported. This is a subset that I've listed here. The whole list would have been totally illegible instead of slightly illegible. But this allows you to break it down by method, by project, or by service, or by response code. Maybe you're suddenly seeing an uptick in a specific response code and you want to dig in. And then, as with all metrics in Stackdriver, you can use group by or filter to help refine, as Liz was talking about earlier. So how do you use these? What we expect you to do with these is to look for correlated SLI degradations. Your product's SLI is trending in a bad direction. See if the GCP products that it relies on are also having anomalies. Look at a baseline. See what it looked like last week or the previous day, so that you know that it's not some sort of cyclic thing that wouldn't necessarily lead to an issue in your product. And use these to drive support conversations. This is going to help you have really efficient, effective conversations with Google support. Things not to do. Please don't assume this is an SLA for Google. We are giving you this for information to help you debug. It's not an SLA. And please don't call every time there's an outlier. I'm sure you have better things to do, and I'm sure our support folks do as well. And lastly, set up alerts based on your SLIs. Don't set them up based on ours. We care if our users are having trouble, but you ought to care if your users are having trouble, not if Google is being a little wacky. If you'd like to learn more about these, there's a demo area on the first floor of Moscone West. If you go all the way to the back of the room, we're near the folks in the red shirts. Stackdriver PMs are hanging out there for the whole conference, so come talk to us. There's also a blog post coming this week to the Google Cloud blog where you can learn a lot more.
So to conclude, today we talked about 4 different things. We talked about why should you adopt SRE techniques? How does SRE help solve operational problems that you may be having? And then we talked about 3 specific ways of applying these SRE techniques, about how to measure your success of your customers using SLOs. How do we reduce your time to resolve and your time to detect using SRE techniques? And how do we debug problems that are somewhere between Google and your own code by using transparent SLIs? So the key messages I want you to walk away with today, is that SRE techniques help you solve your cloud reliability problems. It may be really easy to click a button in the GCP console and get 10 times as many servers. You can't get 10 times as many operations staff at the click of a button. So it means that we really need to invest in automation and engineering for operability in order to be successful in our cloud deployments. And furthermore, I want you to walk away with the idea that having product development and operations at each other's throats is an unhealthy dynamic. It doesn't need to exist. That if you are running your service to a same set of metrics, if you have error budgets and SLOs, that it provides you with common language and flexibility to decide how fast can I push without impacting my user's experience? How can I make sure that I get both adequate reliability and also shipping our users features as quickly as possible? The other thing that I wanted to mention is that GCP helps you, right? We're here to help you achieve higher reliability. We're here to help you achieve higher operability. And the way that we do that is that we embed SRE concepts into Stackdriver to help you operate more like an SRE. And that our products build in all of these SRE best practices so that you can have lower cost of ownership, so that you can reduce the tension between your teams, and so you can scale up. So I promised I'd tell you a little bit more about my team, the Customer Reliability Engineering team. So we're a set of experienced Google Site Reliability engineers, and we've shifted our focus. Instead of focusing on individual GCP products, we focus on helping our customers be successful, helping our customers be reliable. And what form does that take? Well, we help our customers set service level objectives that are meaningful to their users. We help people do reliability reviews so you can tell, is my application engineered to meet these service level objectives that I think will make my customers happy? And if not, we'll give you a list of items that will help you decide where do I want to invest my time to make my system more operable. We also do shared monitoring, right? So Marie told you about having visibility of Google service level indicators to you, the customer. However, we also think that it's important to have support on the same page, that it should be possible for you as a customer of GCP to expose your service level indicators and objectives to us so that support can see on one page your service level indicator being impacted and a GCP service level indicator being impacted and be able to debug and know, is the problem fixed or not, without having to call you up and ask you, is it better yet? So we do things like shared alerting as well. So we'll get proactively notified if a number of customers start experiencing an issue with their service level objectives in a correlated fashion. We also help people that are large customers, for instance, retailers, with critical periods like Black Friday. And then we help you with ongoing operations, things like doing a joint postmortem whenever there's a outage. Maybe there's something that you could do to mitigate and that we could do to mitigate. There's not a reason to do only one of them. We should do both. And we help people be more reliable all the time, whether it be looking at your design documents or helping you do disaster drills. So you can learn more about SRE, both from reading the Site Reliability Engineering book, the first one, which is available for free online at google.com/SRE. You can also go and pay us a visit at the Fifth Nine Lounge, which is located on the second floor of Moscone West. And there we're distributing a book, print copies of a book called the Site Reliability Workbook, which just came out today, fresh off the presses. We'll even sign a copy for you. And furthermore, there's a book coming up in the next month called Seeking SRE, which was written by a person who doesn't work at Google and is a compendium of industry best practices, both from Google and from outside of Google. The Site Reliability Workbook also includes lessons from our customers. Another place that you may want to go to learn more is to attend Jess and Anne's talk at 4:45 p.m. tomorrow. I believe it is in Moscone West. So With that, we have 10 minutes for questions, so please raise your hand, and someone will bring a microphone around, and we will try to answer any questions that we can with the remaining time. Thank you very much for listening to us. Question down there in the middle, please. Please pass the microphone down.
Hi.
It's on. Just keep talking.
All those metrics there seem like you're pulling them from APIs or stuff. Can you pull all that information also from Google Load Balancer?
From the Google Load Balancer, you said?
Yes.
Yes, the Google Load Balancer metrics are given to you through Stackdriver, right?
I haven't seen, we've been using Google Load Balancer for a while, and I have not seen anywhere to pull response codes, times, and anything. So right now, we have built engines in the middle between Google Load Balancer and whatever the backend is, just to pull out metrics. So after seeing all your presentation, I was really curious on how we can get metrics out of the Google Load Balancer.
Can you come chat with us at the Transparent SLIs booth?
Absolutely.
And we'll figure it out.
I really appreciate it. Thank you.
Any
Over
other
there.
questions?
Can someone run that microphone over there, please? And then after that, we'll run the microphone over there to the end, and then we'll go back over.
Hello.
Great, go ahead. Floor's yours.
Do you support custom sources for the SLIs?
That is something that we are working on. We decided that it was most important to prioritize people's kind of HTTP statuses and latency first before we worked on supporting custom metrics. So that is something we're very much interested in. We're interested in your feedback. Like we said, this is a early access. Over there. Someone can run that over there.
And as that's happening, I think we forgot to mention, please rate our talk in the app so that we know how we can do better next time.
This might be an unfair question, but you're introducing a culture shift and thinking that sometimes my executives might have issue with. Do you have tips or case studies on how, introducing SLI versus, uptime improves their business?
Yes, you want to attend Jess and Anne's talk at 4:45 p.m. tomorrow, which is all about the culture shift. There's also a concrete customer case study at the Fifth Nine Lounge, I believe, on Thursday afternoon, where we'll have a customer that I've been working with for several months called Marketo, which will be talking about their experience with adopting their SRE culture. Over here in the front.
So my customers, it's not about like uptime. It's about serving X amount of requests by Y date.
Yep.
So how would I design metrics around, hey, we're getting close and this is dangerous?
That is the difference between a service level objective and a service level agreement, is that you want your service level objective to be set more aggressively than your service level agreement, so you will get paged before you run into the danger zone and fall afoul of your legal obligations. So you might want to set, for instance, a service level objective on throughput, with the idea being that if your service level objective starts degrading, right, like if you have your throughput degrade below the level that you would need in order to complete everything in the requisite amount of time, that you would start getting alerted about it. Does it help?
Yes, a lot.
Great.
Oh, that's loud, sorry. So you mentioned alerting on SLO violations instead of alerting on root causes. In my experience, root causes sometimes are leading indicators of SLO violations.
Yes.
How do you feel about that? And like, how do you approach that?
If a root cause is very, very, very strongly correlated in an advanced predictor, then it winds up sometimes being a good idea to alert in advance. However, most of the time that is not true. Most of people's potential causes are in fact only potential. So I would say it's probably okay to have maybe 3 or 4 potential causes. It's probably not okay to have 100, right? You kind of have to have balance in all things. At the end of the day, it also depends upon your window to react, right? If you have a 3 nines SLA, that gives you enough time to investigate something. And if you have a 5 nines SLA, or sorry, if you have a 5 nines SLO, maybe you're better off implementing some kind of automation to deal with the condition that reliably, predictably leads to degradation in service, right? You would rather write a robot to do that for you rather than alert you with, hey, this thing got, hey, this thing's in danger, and it always leads to a problem, and you always do the same thing. Why not have a robot do that for you? Other questions? Over here in the front.
It's coming.
Yeah, it's coming. It's coming.
So there are a lot of Google services that we use where there is a time for data propagation. So for example, when you add a user to a group in G Suite, or when you change an IAM role or something like that, it says could take minutes or could take up to 24 hours. How do you decide your internal targets versus what you say in the documentation, what that delta really is?
That's a product management thing. Marie.
Thanks, Liz. You're a real pal. It's going to vary depending on the service, and what it will depend on is exactly what we talked about, which is what we think the users are looking for. So for something like adding an IAM role, you probably expect a much quicker turnaround, whereas if you're sending logs to like a storage bucket for cold storage, then you can wait.
Yeah, I'm more thinking what the gap is, though. So, like, a lot of times we see that a propagation could take up to 24 hours, but the reality is it's like 5 minutes. So there's a huge gap between what's
yes,
normal
fascinating
and then
question.
what we.
Yeah, we love that question. So that is an example where the service level objective and the real user experience have diverged from each other. And in those cases, it is usually a thing we recommend as an SRE best practice. Sorry to make more work for you, Marie, right? But we usually recommend as a best practice to either make sure that the SLOs reflect reality or to degrade reality in order to match the SLOs, right? In order to make sure that people get predictable, consistent performance. So yes, you're right to note that that is a gap. And that is something where we probably should either tighten one or loosen one, right? Like when you have an aspirational SLO and a actual on the ground SLO that are de facto different from each other, that's a problem.
So, yeah, you typically wouldn't expect them to be orders of magnitude apart.
Exactly, not orders of magnitude apart. So
we'll go ahead and make that slower then.
Any other questions? One more question. We've got 2 minutes left.
So you talked about choosing your SLIs to match what your users care about. Is there value in trying to go beyond just an HTTP 500 in that sometimes a 400 is actually a problem in our client that the user is still a problem to the user, but those can be a lot harder to detect and understand in a useful way.
That gets to Marie's discussion of measuring user journeys rather than single requests. So if you can measure an entire user journey, for instance, measuring not just, did loading the homepage of my shopping website work, but was I in fact able to add an item to a cart and check out, right? That's going to be a much more robust situation. So the same thing goes for HTTP 400s, right? Like, are users experiencing what they are expecting to see, or are users expecting an abnormal condition? And that's something that you need to make sure that the best possible SLO is a critical user journey, but you have to start somewhere, right? An imperfect SLO is better than no SLO. So start measuring, otherwise you're just taking stabs in the dark.
And so a better framing of that might be something that's not a 200 would be a failure, rather than a 500 is a failure. All right?
Excellent. Thank you all for coming. And if you want to find us afterwards, you can find us at the 5th 9 on the 2nd floor of Moscone West.
Thanks a lot.